Hello dear students, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. I am discussing high-weightage test 8 most incorrect questions in this session. This test was based on ellipse and hyperbola, standard properties like eccentricity, latest rectum, etc. So before we start discussing these questions, I would like to give you few important ideas, formulas, results that you must know before you start solving this assignment. So these are few of the results. Number one, parametric equation for ellipse and then for hyperbola. Dear all, if you are having ellipse x square upon a square plus y square upon b square is equal to 1, whether a is greater than b or a is less than b, a is greater than b or a less than b, in both cases the parametric coordinates are given by a cos theta, y is equal to b sin theta. You can check for both of them. But if you are looking for hyperbola, that is x square upon a square minus y square upon b square is equal to 1, in this case this hyperbola will look like this. It will be opening on right side and left side. Your point in parametric form can be taken as a secant theta comma b tan theta. The other form of hyperbola is actually taken if your equation is x square upon a square minus y square upon b square is equal to -1, or if you want to keep 1 plus 1 on the right hand side, then this will be plus here and this will be minus here. So you can write it in two ways. Okay, in this case your diagram will be like this. Your asymptotes will be like this and hyperbola will be opening either upwards or downwards. So one branch will be upwards opening, one branch will be downward opening. In this case, the parametric coordinate will be at any point you can take p as, instead of taking a secant theta, this will be taken as b secant theta comma b secant theta comma a tan theta. So please take care of this thing. Here parametric coordinate will change. B will be multiplied with secant theta, A will be multiplied with tan theta in this case. Okay. Now coming to the second point, that is eccentricity. One very important thing, dear all, because JEE Mains they have reduced the syllabus of conic section. So what is now left is all these results like eccentricity, latest rectum, that directrix, focus, all related to these things you must know. So the very first thing is eccentricity. Suppose your ellipse is this one where a is greater than b. Okay, in this case please see your eccentricity will be root over 1 minus b square upon a square. Please remember b is less than a, so root over 1 minus b square upon a square. One more thing I'm going to tell you, you might not have seen this before. This angle, if your focus joined with end of minor axis b, okay, then this angle that you can see on the screen alpha, then your eccentricity is also equal to sine alpha. And how it is coming? It is one very simple thing. Please understand how we can get it very easily. We know the difference of focus from center, distance of focus from center is AE. Okay, this distance is B. Okay, one more thing, you know the property of ellipse that sum of any points from the two foci is 2a, the major axis, and because this B point is placed symmetrically, so its distance from focus will be a, its distance from other focus will also be a, because it has to be equal and sum is equal to 2a. So now you can see that sine alpha, because this angle is 90 degree, sine alpha is equal to E directly. Okay, so that is one thing I would like to tell you. And also the result of latest rectum in this case will be 2b square upon a. The directrix, they comes at x is equal to a upon e, and the other directrix comes at minus a upon e. This focus is at ae comma 0 and this focus is at minus ae comma 0. Similarly, if we go to the another ellipse, in this case things will be, you can say, reflected or rather rotated by 90 degree. In this case the eccentricity, because this time a is less than b, when this ellipse becomes horizontal looking ellipse you can say, then a will be less than b and this e value will be 1 minus a square upon b square. And if you compare with this diagram, same alpha, if I draw, it is here. So this same alpha will be equal to sine, the sine of the same angle alpha will be equal to eccentricity. Okay, same logic, because this will be BE this time. Major axis this time will be 2b. So this length will be b, this length will be b. So sine alpha will be BE upon b, that is E. Okay, and this length this time would be A. Latest rectum should be 2a square upon b in this case. So these are the results you must know. This directrix will be y is equal to b upon e. This directrix will be y is equal to minus b upon e. Okay. Now similar results we must know for hyperbola also. In case of this hyperbola, okay, when x square upon a square minus y square upon b square is equal to 1, it is given. Now AB can be equal, less, doesn't matter. Your diagram will be looking like this only. The only difference will be in the wideness, you can say, of the branches depending upon the values of A and B. Now the eccentricity in this case will be root over 1 plus b square upon a square. Okay, and that is also equal to secant beta in the diagram. The beta that I have shown you in this diagram, where asymptote is meeting the transverse axis of the hyperbola at angle beta, then eccentricity will be secant beta also. In this case, focus is AE comma 0. This directrix is x is equal to a upon b, very much similar to what you do in your ellipse. This is minus AE comma 0, and this directrix will be x is equal to minus a upon e. In this case, the latest rectum, let me write it here, the latest rectum will be 2b square upon a. I think it's same as the horizontal looking ellipse, you can say. Okay, in this case when this is minus sign here, or you can put plus here, then minus will be here and plus will be here, it's same thing. In this case, your focus is 0 comma be. Your directrix is y is equal to b upon e. The other directrix is minus b upon e. Other focus is 0 comma minus be. In this case, the eccentricity would be 1 root over 1 plus a square upon b square, and that will be also equal to secant beta. The same angle beta you can compare. This time this beta is not counted from x-axis, it is rather counted from transverse axis in both cases, because in this case transverse axis is x-axis, in this case transverse axis is y-axis. Okay, and the latest rectum length would be 2a square upon b. In this case, here it was 2b square upon a. Now coming to the last thing, that is confocal, ellipse and hyperbola. Then we will start solving the questions. So if you are given one ellipse, one hyperbola, and we are saying confocal. Confocal means their focus should be same. So this focus and this focus S dash, they both are focus of ellipse as well as hyperbola. So you can see hyperbola, ellipse, okay, having same focus. Okay, now if they are having same focus, that means the distance of focus from their centers should be same. So in this case, A into eccentricity of ellipse will be equal to A into eccentricity of hyperbola. Okay, so AEE is equal to capital AEH. Okay, now if you solve it, what do we get? We will be getting A square into EE square is equal to A square EH square. I have done the squaring here. Now we can now put the values of eccentricity of ellipse, that will be 1 minus b square upon a square is equal to a square, and that will be 1 plus b capital B square upon capital A square. So solving, you get a square minus b square here and capital A square plus capital B square here. So that is one result. I will not say you remember it, you just derive it whenever you need it. But I think that is very much obvious as soon as we say confocal, ellipse and hyperbola. Because if their focus are same, their centers has to be same. Okay, so this AEE should be equal to capital AEH. Okay, now the second thing, dear student, that can be important thing for you, the point where they are intersecting each other, let me call that point as P. Okay, now if you join S with P and this S dash with P, then there is a reflection property. If you know, then at this point the angle bisector of these two lines SP and S dash P will be the tangent of hyperbola, and it will be normal of this ellipse. In fact, the external angle bisector of these two lines, that is SP and S dash P, will be tangent to ellipse and normal to hyperbola, which means the tangent at the same point to the ellipse is actually the normal of the hyperbola, and vice versa, or converse you can say, like normal and ellipse, just you change the term for ellipse to hyperbola. So what is the meaning of this thing? The meaning of this is that the point P where they are intersecting, they actually intersect each other at 90 degree. That means in this case ellipse and hyperbola are orthogonal to each other. Orthogonal to each other. So the 4 points that you can see, P may be here, this Q here, you can say R here, sorry, this is R and this is S. So all 4 points, at all 4 points they will be intersecting each other at 90 degree. Okay, so with this I will start solving the questions. The very first question is, if the length of minor axis of ellipse is equal to distance between this foci, between its foci and corresponding directrix, then square of its eccentricity is. What I will suggest whenever you see such things, although you may remember all the results, but I will still suggest you that you make a small diagram, because you get sheets, there is no problem of space. So just make the diagram and then see what exactly they are saying. So length of minor axis, so minor axis length is 2b, which means distance between this point B to this point B dash, you can say, and that is equal to distance between the focus, that is focus here, and directrix here, that is x is equal to a upon e, and we know the distance from this to this is ae. So this distance will be a upon e minus ae, distance between focus and corresponding directrix. Then we have to find the square of eccentricity. So the one method could be that we just apply that result of eccentricity, square it both sides, so it will be 4b square, and to b square I can write a square into 1 minus e square, and this will be, if you take a common and take LCM, so 1 minus e square upon e and whole square of this thing, because we did squaring. So after taking LCM and all these things, you have to do the squaring also. So you can see this a square will cancel this a square, and one of the 1 minus e square will cancel 1 minus e square here. E cannot be 1 for ellipse, so we can write this as 4 into e square will come this side is equal to 1 minus e square. So this gives you e square is equal to 1 upon 5. That can be one method. Okay, now I will tell you one more method, although that is a very good method, there is no problem in this, but just to explore other methods. As I told you that this angle here, if it is alpha, okay, then sine alpha is e. So the method 2 I will be doing it here. Okay, so this, if this angle is alpha, e is equal to sine alpha. Now what we are given, this length has to be a. Okay, so this length is b, and we are given that 2b is equal to distance from this to this. Okay, now dear students, I think this length you can write directly, it will be a upon sine alpha. Okay, whereas this ae, this length from this to this, if you use this triangle, will be a sine alpha, if I'm not wrong. Okay, and also this b would be actually a cos alpha. This b will be a cos alpha in this diagram. So just use this thing. So instead of writing 2b, let me write this as 2a cos alpha. And on the other side, the distance between this to this would be a upon sine alpha, a upon e minus a sine alpha. Okay, now just solve it and you will get the value of, I think, 10 alpha. you can cancel a, so you will be left with 2 cos alpha on the left hand side. On the right hand side, it will be 1 minus sine square alpha upon sine alpha. Okay, so this will become cos alpha. 1 cos alpha you can cancel, so that will be 2 is equal to cos alpha upon sine alpha. Okay, so what we are getting, let me go to the next slide. So we are getting cot alpha is equal to 2, and we know eccentricity is sine alpha. So from cot alpha to sine alpha, you can write it as, because this will be base upon perpendicular, so perpendicular will be 1 and root 5 here. So that is e, and square of this would be 1 upon 5. Okay, so you can do both ways. One method was the conventional method. The other method is this angle alpha. If you know, then these sides you can write all in terms of a and sine alpha cos alpha, and then solving you will get the value of e. Coming to this question, where we are given hyperbola has foci at 0, plus minus 5, and asymptotes have slope plus minus 4 upon 3, and we have to find the length of latest rectum. Now in this case, you can see, first let us make a diagram. Okay, so your asymptotes are like this, and your hyperbola, this time because foci is 0, 5, so it has to be up opening one branch and down opening another branch. Your focus S will be here 0, 5. I will take just one branch. I think other will be just the replica or image about x-axis. In this case, you know the BE will be equal to 5. Okay, and the slope of asymptote, suppose this angle is theta, so this tan theta is given to us as 4 upon 3. Now if this angle is beta here, and I told you the eccentricity would be secant beta. We can do it otherwise also, but if you know this thing, I think it becomes very easy. So E is equal to secant beta, and this tan theta means tan of 90 minus beta is equal to 4 upon 3. This gives you cot beta value is equal to 4 upon 3. Now we are looking for secant beta, so I think this will become 5 upon 4. If it is 5 upon 4, BE is 5, I think the value of B comes out to be 4. The value of B comes out to be 4. Now what are we looking for? I think we are looking for latest rectum, length of latest rectum, which will be for this hyperbola should be equal to 2a square upon B. Whereas the relation of a square is equal to b square into e square minus 1. Now just put the values. So 2b is equal to 8, e square minus 1. If you solve it, I think you will get the answer. Let me do this calculation here. So this will be 2 into b, that is 8, and e square is 5 by 4, 25 by 16. So 25 by 16 minus 1. So this will become equal to 9 upon 2. Yeah, 9 upon 2 will be the answer of this question, that is A. Okay. Now coming to the next question. See, in this case of eccentricity E, okay, because we have given the slope of asymptote. So without knowing this property, that angle of asymptote with conjugate axis, with transverse axis, if it is beta, then eccentricity is secant beta. It will be bit difficult you to calculate this question. So please remember it. It will be a useful thing. The answer was A only. Now coming to the next question. It says t equal to 0, t belongs to 0, 1, where E1 is the square of eccentricity of this hyperbola and E2 is square of eccentricity of this ellipse. Okay, so in this case you can see this E1 square. This E1 square would be, let me use, yeah. So E1 square would be for this hyperbola 1 plus b square upon a square. If you take LCM, it will become 1 upon t square. And then E2 square, that is the square of eccentricity of this ellipse, it will be 1 minus b square upon a square, so 1 upon 1 plus t square. So this, if you take LCM, will be t square upon 1 plus t square. Okay, now we have to find the sum of these two. So that is k is equal to e1 square plus e2 square. So here it will be 1 upon t square plus this, I can write it as t square plus 1 minus 1 upon 1 plus t square. So we will be getting 1 upon t square plus 1 minus 1 upon 1 plus t square. Now you can use AOD also, but I have an idea that you write these two terms after combining. So we will get 1 plus, if you take t square into 1 plus t square as LCM, t square into 1 plus t square as LCM, I think it will be just 1. Now, because t is between 0 to 1, so t square is also between 0 to 1. So as your t increases, I think t square as well as 1 plus t square will increase. So the value of k can be directly found by putting t is equal to 0 and t is equal to 1. T is equal to 0 you cannot put, but you can find the limit, and also there is an open bracket. So at t is equal to 0 or t is equal to 0 plus, you can say k will become infinite. Whereas for t equal to 1 or approaching to 1, because we are having open bracket, so this k will be equal to, I think, 3 by 2 after solving. So the range should be 3 by 2 to infinity of this question. Some of you might do differentiation. Some of you might do differentiation at this stage. That is perfectly fine, and you will find this function is becoming strictly decreasing. So less value will give you highest answer. Less value of t will give you highest value of k, and the highest value of t will give you the least value of k. So that way also you can find the range of this k. Now coming to the next question. Okay, this is done. Yeah, area of quadrilateral formed by intersection of points of ellipse and the circle. Now dear students, try to understand. I will make this circle, I think, which is having center at origin and radius is equal to 4. Now the point where ellipse will intersect this circle, I can assume that point to be 5 cos theta comma 3 sin theta in parametric coordinates. 5 cos theta comma 3 sin theta. Now this should satisfy the equation of circle. So it will be 25 sin square theta plus 9 cos square theta, and that is equal to 16. I can split 25 as 9 plus 16. So 16 sin square here plus 9 sin square plus 9 cos square is nothing but 9 is equal to 16. You can take this 9 to the other side. You will get this to be 7. So the value of sin theta or sin square theta is coming out to be 7 upon 16, and cos square theta value will be just 1 minus sin square theta, so 9 upon 16. Okay, now dear students, we can say by symmetry, if this is the point, one point of intersection of ellipse with circle, the quadrilateral that we are going to get should be of this form. It has to be some rectangle, because if this is 5 cos theta comma 3 sin theta, this will be just minus 5 cos theta comma 3 sin theta, because only x coordinate will become negative, y will be same. Here this will be 5 cos theta minus 3 sin theta, and here it will be both negative negative, minus 5 cos theta comma minus 3 sin theta. Okay, now you can see this will be one rectangle. Its area has to be equal to, this side would be 10 cos theta and this side should be 6 sin theta. Okay, now this is 60 into cos theta value is 3 upon 4, sin theta value is root 7 upon 4. So this 4 will cancel this 15 times. So 15 into 3, 45 root 7 upon 4. 45 root 7 upon 4, that is D should be the answer of this question. Okay, I think that is best method, I will say, because your calculation is least, although you may solve these two as linear equation in x square and y square. That will give you x coordinate and y coordinate of their point of intersection. That can also be done, but if you know parametric coordinate, I think it is much better. Okay, here I think they have solved that way only, solving for x square and y square, and then doing this 2 into x into 2 into y will give you the answer. Now this question, area of smallest circle passing through the foci of the hyperbola. So this hyperbola is actually x square upon 8 minus y square upon 8 is equal to 1. Those who remember, if a becomes equal to b, and those who do not remember, it's almost same thing. The eccentricity is equal to 1 plus b square upon a square, because some people remember that this is rectangular hyperbola because both a and b are equal and its eccentricity is root 2. But it doesn't take much time even if you don't remember it and you find it here directly. Now in this case your focus would be AE. So A is 2 root 2, 2 root 2 into root 2, so 4 comma 0, one focus, and the left hand side focus would be minus 4 comma 0. Now they are saying area of the smallest circle passing through the foci. So if you know these 2 points and we want a circle that is having smallest area, it is only possible if you choose this as a diameter of the circle. Okay, because this has to be one of the secant of circle. If it is not diameter, that means diameter will be bigger than the secant, and then your circle will have larger area. So this has to be your diameter. So I think it is done, because your diameter is 8, your radius is 4. Radius is 4, so area would be pi r square. So 16 pi should be the answer of this question. Now next question, hyperbola conjugate axis is twice its transverse axis. Okay, so 2 times b. If I write the equation, this one, x square upon a square minus y square upon b square, if we use this one, it will be 2 times, the conjugate axis, that is 2b, is 2 times its transverse axis. So b is actually equal to 2a. By the way, you can check all the options and see in which options we are getting b is equal to 2a. In this case, your a is root 20, a is root 20, and b is root 5. So it is opposite actually. Your a is 2 times root b. I think in this case it is matching. In other options it is not matching at all. So answer should be C only, but let's completely solve it. Okay, so b is equal to 2a, and then they are saying the distance between the foci. Distance between the foci for this ellipse, this hyperbola, should be actually 2ae, and that is given to us as 10. Okay, so b is equal to 2a and 2ae is 10. So using these two and relation of eccentricity, I think we can find the relation. So how we can do it? So I will use it here. If you square both sides, b square will be a square into 1, sorry, not 1 minus, it will be e square minus 1. It will be e square minus 1 because it's hyperbola, and this is equal to 4a square. So this a square will be cancelled. So the value of e square is coming out to be 5. So if we know e from this, because ae is 5, so we will know a is equal to, I think, root 5. E is root 5, a is 5, so a is root 5. A is root 5, b is, I think, 2 root 5. So you get your answer from this. Dear students, I would like to tell you one thing here, that although we took standard hyperbola whose branches are opening right side and left side, but one more answer could have been if x square upon 20 minus y square upon 5, and I write equal to minus 1, because in this case when it is minus 1, this will correspond to transverse axis, this will correspond to conjugate axis. So this will become correct answer. So if instead of 1 it was minus 1, a option would have been correct. Okay, so please take care of this thing, because they have not mentioned which hyperbola they are asking. Only they are asking hyperbola which is satisfying these properties is. So you just have to check whether right left opening or up down opening. So but whatever you are taking as answer, it should satisfy whatever given here. Okay, an ellipse and hyperbola are confocal. The length of minor axis of ellipse is equal to length of conjugate axis of hyperbola. So minor axis of ellipse means b, or 2b you can say, and that is equal to the length of conjugate axis. Conjugate means 2b, and I am using ellipse as x square upon a square plus y square upon b square is equal to 1, where a is greater than b. and hyperbola I am using x square upon capital A square minus y square upon capital B square is equal to 1. Okay, so they can be confocal because its major axis will be along x-axis where focus will lie, and its transverse axis will lie along x-axis where focus will lie. So 2b is equal to 2b you are given, 2 small b is equal to 2 capital B you are given. Okay, and they are confocal. If their eccentricities are EE and EH, we have to find the value of this expression. So dear students, what we can do, one thing is this, and another thing is, if you remember from the diagram, your AE has to be equal to capital AEH. So AEE should be equal to AEH. Okay, now using this, you can find 1 upon E square 1 upon E square E plus 1 upon E square H. So let's do some calculation. If I square this thing, so this will be B square is equal to capital B square. We do it here. So B square will be equal to A square into 1 minus E square is equal to, that will be capital A square into E H square minus 1. Okay, now using this I think we can find whatever we are looking for. Okay, so we are looking for the relation between the eccentricity, so it will be better I write this small a in terms of capital A. So this small a will become capital A square into EH square upon E capital E square into 1 minus EE square, and that is equal to capital A square into EH square minus 1. So this capital A square get cancelled. So what are we left with is 1 minus EE square upon EE square is equal to EH square minus 1 upon EH square. Okay, so we can do this calculation here. 1 upon EE square plus 1 upon EH square. Okay, just split the terms and you will be able to see that 1 upon EE square coming here minus 1 is equal to 1 minus 1 upon EH square. So this becomes equal to 2. Okay, so answer for this question will be D. Okay, so that's it in this session. I would like to talk about this confocal thing because there have been questions in JEE Mains. So please take care of this thing. Please attempt this question, or if there are more questions, please attempt those questions also based on confocal ellipse and hyperbola. So that is all for this session. Thank you so much. Bye students.